Hello and welcome to day number 12 with the Maker Advent Calendar. Today we're going to open up box number 12. So it's the final day of our 12 Projects of Codemas Advent Calendar. Today we're planning with an RGB LED strip, but these aren't regular LEDs. These are addressable LEDs, meaning we can code all sorts of colours, patterns and sequences. Time for some ultra festive blinky. So in box number 12, you'll find a custom addressable LED strip with male jumper wires. Today's a big one. We're going to learn how to light up the LEDs in our strip individually, how to code different colors and color lists, how to create a light chaser, then a light chaser speed controller using our potentiometer from day 4. Some button color control, then fading effects. So before we start, let's talk about what an addressable LED is. The LEDs in your strip are WS2812 addressable LEDs, sometimes called neopixels. These are a special kind of LED that actually contain 3 small LEDs inside each, one red, one green and one blue, which we mix to create lots of different colors with our code. This is why it's called an RGB strip. Red, green, blue. We'll talk more about that in a moment. Each of these LEDs has a tiny controller chip inside that allows us to address each of them individually in our code. Unlike more traditional lighting options, which light the entire strip in a single color. However, because of this, they always need a microcontroller to tell them what to do. With much longer strips, you would usually have to worry about external power, resistors, and other technicalities. However, the compact custom strip in your box is short enough to allow us to avoid all of these distractions. We will be powering it from a different pin this time though, the V-bus pin, physical pin number 40, as this will provide the full 5 volts the strip needs rather than the 3.3 volts pin we've used so far. We've also had this LED strip made especially for this calendar, with handy jumper wires so you don't need to mess around with connectors and tools. So let's construct the circuit. Let's disconnect our Pico from the USB port on our PC. We're starting with a mostly bare breadboard, so remove any other parts that may still be in place from yesterday, which should look like this. So let's just take everything off. All the wires, the button, the OLED screen, and move all this out of the way. So now we are just left with our breadboard. Next, grab your LED strip and fit the 3 wires as follows. Well, it's a long one. Whee! Place the red wire into physical pin 40. The black wire into the ground pin, which is physical pin 38. And fit the green wire into pin 34. So 38, 37, 36, 35, 34. So now we should have something that looks like this. Yay. Next we add one of our buttons and the potentiometer. Fit them to the left of the Pico as shown below. Remember that your potentiometer will have a gap between each of the legs, unlike our diagram. Potentiometer, and the button. the potentiometer, and the button. Let's wire the button next. Our button will need the usual 3.3 volt, not the 5 volt on the V-bus pin we're using for the LED strip. Connect the left leg of the button to the upper red channel. Connect the right leg of the button to pin number 20. Then use another wire to connect the 3.3 volt pin to the upper red channel. Finally, we connect the potentiometer with 3 wires as follows. Connect the left leg to the ground pin on physical pin number 18. So left leg, ground pin 18. And then we want to connect the middle leg to GPIO 26, which is the physical 31. So 28, 29, 30, 31. And then we want to connect the right leg to the upper 3.3 volt channel. So now we have everything wired in as it shows in our diagram. So activity 1, minimal starter program, 1 LED. Time to twinkle, plug your Pico back in to the USB port on your computer and we'll get things set up. Now, whilst we could just straight into something flashy and colourful with all the bells and whistles, we want to guide you through some easy examples first so you can understand how the code works. This minimal example lights the first LED in red, just to get to grips with how the library works, which is now included within MicroPython, so we don't need to install anything. These strips can show lots of different colours as they are RGB strips. So RGB stands for red, green, blue. It's a colour system used in computing to display colours on a computer display. The 3 colours can be combined to show a huge range of different colours. With RGB, each of these 3 colours can be set to an intensity value between 0 and 255. As each of these 3 colours has 255 possible different intensity values, technically there are 16,777,216 possible colour combinations, although your eyes probably wouldn't notice the difference between a lot of these when they're used with their LEDs. How does this relate to our LED strip? Well, as we mentioned earlier, inside each of the clever LEDs are 3 smaller LEDs, 1 red, 1 green, 1 blue. We send code to the strips to set the RGB intensity value for each LED, allowing it to mix and show different colours. There are lots of online tools to help you find the RGB values for your desired colour, such as this handy page from Rapid Tables. Our example code imports NeoPixel, which is the name of the library now included in MicroPython to drive these kind of addressable LEDs. To set the LED strip up, line 7 sets the pin number for the strip, GPIO 28, and the number of LEDs on the strip. We can now refer to using strip in our code. To send data to the LED strip, we first write what we want to do with it, then use strip.write to send it to the strip, a bit like how our OLED display worked yesterday. In the example below, we use strip. The 0 is telling our strip to drive the first LED only, because the first LED starts at 0, the second is 1, and so on. The numbers in the brackets are for the RGB value. We're using 255, which is red at the brightest intensity. Copy the example below over to Thonny, run the code, then try the following tasks to get the hang of things. Okay, let's copy the code, paste it into Thonny, stop and start. So now we can see that our LED, our first LED is showing. So now it says try changing the 255 to 10. So in our code, if we change that to 10, stop and start. Okay, so it goes a much duller color. The intensity is much less bright. Try changing the RGB value to 0, 10, 0. 0, 10, 0. Okay, so must be red, green, blue. Now try changing the 0 to 7. What happens? It should light the 8th LED because remember the LED number starts with 0. So the 0 from strip, let's stop and start. So now the colour's all, now the LED that's lit is all the way around here. So 0, 1, 2, 3, 4, 5, 6, 7. Use an online RGB colour finder tool to identify and display your favourite colour. So let's go to Rapid Tables and let's pick blue. Okay, let's pick blue. So it's 51, 51, 255. So 51, 51, 255. And we'll go back to using a different LED. So we'll stop that and click start. Okay, so that's really good. That's a blue. Very bright. Okay, so activity 2, using multiple LEDs. Our next step is to drive more LEDs in our strip. We'll first show you a basic method of doing this, then a more efficient method, and then a much better method which will keep your code nice and compact. To light more of our LEDs, we need to tell MicroPython which LEDs we want to send data to. So far, we've only told MicroPython to light up LED 0. A basic way to do this is just to add more lines, changing the 0 to whatever number LED we want to light up. The example below does exactly this, which will light up the first 5 LEDs in red on your strip. Then we'll show you a better way. So let's paste the code, stop and start. Okay, so we've got the first 5 LEDs showing on our strip, all in red, 255. So a better method. Let's improve our code to save the number of lines we're using whilst making things a bit clearer. The only thing our code is changing is the pin number for each of the 15 LEDs, so we can make use of a for loop in the range function that we've used previously. We use a for loop to iterate over each LED on our strip. We know we have 15 LEDs, so we use for I in range 15 to tell this code block to iterate over a range of 15. This range is injected into our LED strip line as we use strip I equals 255, 0, 0. It does this for the entire range of 15 LEDs. Then, once the loop has completed, the final line writes the data to the strip, which makes them all light up. This still isn't the best way to simply fill the entire strip, but this example will be useful later on when we want to run some effects, so it's a good one to try. Try the example code below to see for yourself. stop and start. Okay, so let's making them all go. Okay, so the whole strip's on now. Want to simply light the entire strip without any flexibility? It's super simple. Just use strip fill 255 and it will light as many LEDs as you have to find in the setup line. Make sure you use 2 sets of brackets with this one. Try the simple code below, then have a play around with the RGB colours. Oh yeah, that's a nice blue. So let's change that to 100. Let's change that to 60. Change that to 90. Stop and start. Oh yeah. Nice cool colour. So activity 3, better colour management. We now know how to light multiple LEDs and we know how to create RGB colours. Let's show you a few tricks to help you manage colours a little easier. Then we can move to some really fun stuff. Your program currently uses the RGB values to set a colour, but when you're looking back and reviewing your code, it can be difficult to remember what they are. A better way is to create colour variables with the colour's name. We've used variables a lot over the last 12 days, so you might already know what to do here, but we're going to show you just in case. We're going to take the example above and add variables for 5 different colours. We can then use these colours in our LED strip code to easily change the colour by just changing the colour's name, such as strip I equals red. Give the code below a try and then try changing the colour name in the brackets to form one of the variables. So let's copy the code, paste it into Thonny, stop, and then start. Oh, awesome. So we've got pink here. Give the code below a try and then try changing the colour name in the brackets to one of our variables. So let's change this to blue. Stop and start. Oh, excellent. So basically what we're doing here is whatever colour we add in the name of our variable, it will then apply the intensity setting here. So if I type in red and then stop and start, then we'll get red. If we put green, stop and start, then it will show green. And if we put in yellow, stop and start. Excellent. Now that we have our color variable set up, we can also create a list of these colors, which we can use later in a for loop to iterate over, allowing us to work through a selection of colors in our code. But what are the lists in MicroPython? Lists are another handy tool for your MicroPython toolbox. They are essentially a variable with multiple items inside. The item inside can be any data type, strings, integers, variables. Let's run a quick example and then we'll use lists in the next activity. The short example below creates a list called myList and includes 4 strings inside square brackets separated by commas. In our example, we then print this list by using the list name in the print line. Pop this into Thonny and give it a try. Okay, so now you can see in the shell script it's showing Dasher, Dancer, Prancer and Vixen just by using that one line. Activity number 4, Light Chaser. Let's step it up a gear and create something really cool, a light chaser. In our example below, we've created a list of color variables called colors. We have also placed our LED code in an endless while loop, which contains a for loop with a nested for loop inside it. A nested for loop allows us to iterate over the colors first, then iterate over the LEDs. The code is saying, for every color in the colors list, run my code block. And that code block then includes another for loop that runs this color through the range of 15 LEDs. Once the range has run out, it jumps back to the initial for loop for the next color and it does it all again. We use J for colours and I for the LED range. If you remember from previous boxes, it doesn't matter what we use here. We could use colour instead of J and LED instead of I. There are no rules here, just traditions. Another key change is when we write the data to the strip. Earlier, the strip.write was outside of and after the for loop, waiting for the loop to finish setting all of the 15 LEDs before writing data. This time, we write the data within the for loop after each iteration. This means the for loop finds the next LED in the range and lights it up before moving on to the next LED, which gives a chasing effect to the LED strip rather than writing all 15 at the same time. We also use a simple time delay before writing the data to set the speed for the chaser. That's a lot to take in, so try the code below and reread the above whilst watching it dazzle. We'd also encourage you to add more colours and play with the time delay. So let's copy, let's paste, stop, and start Thonny. Oh yes, that's fantastic. Okay, so let's add a previous colour. Well, let's add all these variables in. Okay, and then we'll go red, green, blue, and then we add in yellow and pink. So let's stop and start. So we've got red, green, blue, yellow, pink. Excellent. Activity 5. We're now going to reintroduce our potentiometer to our code to allow us to control the speed of the light chaser. We will use the potentiometer ADC reading and use this to drive a variable for the time delay, just like we did in box 4 to control the speed of the flashing LEDs. We don't have to change our original light chaser code. Much to achieve this, we simply add ADC to our imports, set up the GPIO pin for the potentiometer, add a line of code within the nested for loop to read the potentiometer into a variable, then divide that number to make it more useful as a time delay. Use that reading variable to drive our time delay. Copy this over to Thonny and give it a go. As you turn the potentiometer left, it should reduce the time delay and make the lights chase faster. So let's copy, paste, stop, start. Oh yeah, look at that, that is pretty quick. Okay, so let's change. Okay, so as I turn it up, that's gone really, really slow. And as I turn it right down, that's really, really quick. So if I turn it all the way up to the top, that is a huge delay. Huge delay. Let's speed that up again. Let's make it super flashy. Activity 6, button color control. We're going to hop back to using strip.fill to completely fill our LED strip with a single color. However, this time we're going to use our button to change our color of our strip. This sounds simple, but we need to change our approach to make it work. Instead of entering the color directly into the code using something like strip.fill red, or using a for loop to automatically iterate through our list of colors in order, we're going to use another method which uses the index of each color in our color list. Each item in a list is given an index. This means that each item in a list is given a number, starting from 0. Let's take our current list, which is red, green, blue. The index for this would be 0, 1, and 2. 0 equals red, 1 equals green, and 2 equals blue. We can use this to pick a specific color from our list by changing how we use the strip.fill line. For our example, strip.fill colors 1 will use index 1 from the colors list, which is green. You're probably thinking, but we could just use strip.fill green. This is true, however, as the index uses a number, it allows us to easily change that number and therefore the color with the button using variables. Our code also needs to know the length of our index so that our code doesn't try to use an index number that is outside of our list's range. For this, we use len followed by the name of the list in brackets. If our list looks like this, colors equals red, green, blue, then we would use len in the following way to count and print how many items are in our list. Try the following example to see this in action. So copy, stop, and start. So in the shell, now it just says that there's 3 colors defined. This is where everything above should come together and make sense. Our code example below has some new variables. MyIndex. We use an index number to select a color from our list. We change this number when the button is pressed to move it to the next number in the index. Index length. This counts the number of items in our color list. However, as we're using this to identify the last number in our index, we have to -1 at the end because there are 3 items in our list. But as these will be indexed as 0, 1, and 2, we want the maximum indexed value to be 2. The example code below uses a while loop that does nothing until a button is pressed. Once the button is pressed, it uses an if statement to check what the current myIndex variable is. If the myIndex variable is less than the index length variable, it will add +1 to the myIndex variable. We also use an else statement under this, which resets myIndex back to 0. Regardless of whether the if statement or else statement is triggered, both will alter myIndex variable, then move to the code below them. These final lines of code update the strip.fill with the index number using the myIndex variable, and then writes the data to the LED strip. We only write the data to the LED strip here, as this means that the data is only written when there is a change. If the button isn't pressed, then nothing happens. Have a good look through the code example, then copy it over to Thonny to try it out for yourself. So let's copy this over, paste it into Thonny, stop and start. So now if we press that button, then the colors cycle through red, green, blue. Activity 7, fading. Now let's try fading our LED strip in and out. It's surprisingly easy with some simple for loop code, and it gives us a chance to show you another way to use the range function. Our example below uses a while loop with 2 for loops inside it, both using the range function. These for loops iterate the red R value used in the strip.fill line below them, so that each iteration changes the R value. You can see where we use I instead of a value in strip. You'll also notice that the range brackets contain 3 numbers, whereas previously we've just specified a single number to iterate over. Using these 3 values lets you specify the start of the range, the end of the range, and the step for each iteration. Our example below uses for I in range 0, 255, 1, which is setting the start of our range to 0, the end of the range at 255, and telling the code to increase by 1 step each iteration. What this does is change our red value by 1 step every iteration, starting at 1 and ending at 255. This creates a fading effect as the intensity moves from 1 dim to 255 bright, very quickly using the delay we have set. The next for loop does the same thing but in reverse. Yes, you can go backwards with the range function. So set our range to start at 255 instead of 1 and end at 1 instead of 255. The step is -1 so that we continually take 1 away from the starting value. Try the code below and try playing with the color values. Copy, paste, stop, and start. Okay, so that's fading. Okay, so this is currently going 1 to 255, and now it's suggested we go 255, to 1, and then here we have to put -1. So let's stop that and start. Oh yeah, very different intensity. Wow, that was a big day. Day number 12, the last one of our Maker Advent calendar. We're pretty sure most of you will be turning your strip into a fancy monitor backlight. Perhaps some will combine it with the PIR to turn it on whenever there's motion in front of their PC. Or maybe some cleverly hidden brake beam sensor will be used as a hand-activated color changer. Whatever you make, we'd love to hear about your projects in the comments section. So what did we cover today? We've learned what an addressable LED is and why they're so fun, built a circuit with addressable LEDs, learnt about RGB and how to create colors with RGB values and where to find them, learned how to code addressable LEDs with MicroPython, learned different ways to light the entire strip, some more efficient than others, created color variables, learned how to create and use lists in MicroPython, including list indexes, used nested for loops, learned how to use len in MicroPython, faded addressable LEDs using range, both counting up and down. That's it, folks. It's the end of the Maker Advent calendar. We know many of you wanted this to last a traditional full 25 days. However, the world is in a funny old place right now, and we wanted this to be as affordable and accessible to as many people as possible. We really hope you've enjoyed following along each day, and we really hope you'll continue your journey as a maker, using your selection of components to make fun projects, experimenting using different parts together to make awesome projects. We've only just scratched the surface on what's possible with this fantastic little microcontroller and the components you've discovered over the last 12 days. There's so much more to learn and experience. If you would like to expand your selection of components for the Pico, the store is full of goodies. Be sure to check out our dedicated Raspberry Pi Pico section too. The internet is jam-packed full of projects and examples using the Raspberry Pi Pico and MicroPython, and 99.9% of this information is free, so don't stop now. We've even had some great examples from makers in the comments section of the calendar along the way. Search engines are your best friend, and when it comes to making and coding, forums, blogs, tutorials, social network groups, and more are at your fingertips and hold the endless amount of examples, code snippets, previous discussions, and useful information. A good starting place for inspiration and a great community is the Raspberry Pi forum, specifically the Pico section. Just don't forget to always search before asking a question. Thank you very much for watching my videos for the last 12 days. I'll be sure to be making some of my own projects using the components that we've got over the last 12 days. So look out for those. See you later. Merry Christmas and have a happy new year.